Hello guys, I hope all of you are doing well. In this video, we are going to discuss our question, trapping rain water. So in the input, we are given number of non-negative integers that represent elevation, where the width of each bar is 1. And we are required to calculate that how much water it can trap after raining. Let's understand our question better. Okay, so this is our input array, right? Here as in the zeroth index, nothing is present, so that means it's zero value, right? And here it is one value again, nothing is present, so zero value. So what we are required to compute is total water trap, right? That's our task. Now what will happen? Rain will happen. So let's see. So rain will happen, and after rain water will get trapped. Let's see where water will get trapped. So here water will get trapped, and how much water will get trapped, as we are given in the input that this is one width, right? So here we can say 1 unit of water will get trapped. Now let's see here. Here also water will get trapped here, right? Here. So how much is this in total? This is 1 unit, right? This is, you can say, 2 units, right? And this is 3. That this is also one. This is 1 unit. This is comprised of total 2 units, and this comprised of 1 unit. Perfect. And where else? Here also water will get trapped. Now, what will be our output? Our output for this array will be 6, right? 1, 2, 3, 4, 5, 6. Now let's see when water is exactly trapping. So let's first talk about zeroth index. Will water get trapped here? No, because zero index got nobody in the left that can hold the water, right? So it will eventually flow away. So here no water will get trapped. And same for the last index. Here there is no building at the right, right? No elevation at the right. So here also water cannot get trapped. Okay, now here let's talk about 2 index. So here why water is trapping? Because it got a building both at the left and both at the right. So let's see for 2. Okay. So 2th index. So 2th index got a building at the right, as well as in the left. It's of 1 height and it's of 2 height. So this is for, let me erase it. And its height is 0. So how much, we are talking about 2 index, right? So how much water is getting trapped here? First, let's not think about how much water is getting trapped. Let's talk about when water is trapping. Okay. Now let's see for 5. For 5 index. So here for 5 index, right? We got a building at the left, right? That is 1. As well as in the right we got a building 1, right? So here also we got a building that can hold your water. So here also that's why water is storing. Are you getting me what I'm trying to say? Let's see this example so you understand it better. Okay, so here we got 1 height, and in the left we got 2 height, and the right again we got 2 height, right? So if we got a greater height, right? If we got greater elevation in our left and right? So that means our water will get trapped. Are you getting me? So for 0th index, we discussed that there is no left elevation, so no water will get trapped. So I hope you understand when our water is trapping. Now, I want you to think about how much water is trapping, how much water is exactly trapping. Okay, so let's talk about 2th index. We can see the right maximum, right? Whatever is the minimum of right maximum and left maximum minus your height, that much water is trapping. So here its height is 0 and its left maximum is 1 height. So here 1, let's show me through red pen. So here 1 unit of water is getting trapped. Now let's talk about this. Fourth index. Here, how much water is getting trapped? So as we can see, here its left max is 2, its right max is 3. So whatever is less, we know 2 max, minus your height. My height is already 1. So here what it indicates that you can store 2 units of water, but I already got 1 height. So can I write this formula? Can I write this formula? Max left and max right. Whatever is the minimum of max left and max right, right? Whatever is the minimum of max left and max right, that much amount of water you can store at your index. Perfect. So here, as we can see in the ninth index, so here it is equal, right? Your max left and max right. So that means you can here store 2 units of water. But we already got 1 height. So that we can only store 1 unit of water. So I have got a right minus my height, minus my own height. So that much unit of water I can store. Now that we know how much water we can store, right? Now let's talk about how we can solve this. Let's talk about the brute force approach. Okay, here I'm going to write brute force. Okay, so can we say, if we know the max left, right, and the max right, again we just discussed, if we know the max left and the max right, right, here if we know the max left and max right, and I calculate its minimum and minus my own height, so I will get my answer, right? And how will I calculate my max left? So if I am at a point, let's say I am at ninth index, so I represent ninth index, so my I will traverse till 0, right, to calculate my max left, and same for max right, my I will traverse till the last, till n minus 1, right? So this will give me my max left, this will give me my max right. So by this I can calculate that how much water will get trapped here simply by deducting my own height. Perfect. Now we know that this is not the most optimized solution. Why is that? Because this solution, it's going to take time complexity of O(n) square. Why? Because every time we traverse, we are going to traverse again to calculate max left of every element, and same for max right. So this is a costly operation that is going to take O(n) square time complexity. So now what is our task? Our task is to optimize it. So let's see how we can optimize it. So here, if we take a stack and we keep calculating its maximum, right? If we know max left and max right of every element, can we calculate? Of course we can calculate. So this time, instead of running a loop, we are gonna do this step using a stack, right? Again, let's see one more. Let's see it again how we were calculating. So for 2th index, its left max is what? Its left max is 1 and its right max is 2. So whatever is the minimum minus your own height, right? Let me write it here again. Minimum of left max, right max minus my height. That's what we are doing, right? Here also, let's see. Here, 1. What is 1 left max? It's 2. And right max is 3. So here, this much water I can store. Now for 5th index, its left max is 2 and right max is 3. So again, 2 units of water I can store. For 6th index, left max is 2, right, and right max is 3. So again, 2 units of water I can store minus my height, so 1 index. And Here, why we can't store here? Because there is no left max or right max. Here also there is no right max. Right? As you can see, there is no right max, so you can't store water here. Here, we got both left max and right max. That is equal, so you can store 2 units of water minus your own height. Right? As you can see, that's 1 unit, again 1, right? Then 2, then 1. So it's our output is 6. Perfect. Now, this is one approach, right? This is one approach, but this time we are going to discuss a different approach. Okay. Also, if you have not watched our question, largest area histogram 2, largest area histogram 2, I suggest you to watch that because we are gonna do the same thing we did in that question, right? I hope that you remember that question, and if you have not watched that video, do watch that video and come back to this video. Okay, so in largest area histogram, what we used to do, we used to calculate the next greater element, the next greater right and next greater left in one traversal. Okay, so let's see for 2th index again. So here its next greater right is 2, right? Its next greater left is 1. So we get our height here. But I want to show you that what we are going to exactly do here. So let's talk. Okay, let me erase it. Then you will understand it better. Stay with me, okay? It might be a little bit confusing right now, but stay with me. You will eventually understand what I'm trying to say. Yeah. So in the largest area histogram 2 question, we used to compute what? We used to compute next greater right and next greater left. Okay. So for 1, what is next greater left? Right? It's first maximum, or you can say here first max. Right? And here also first max of right and left. So here for 4th index, what is it? Next, what is his right max? It's 3 and its left max is 2. So by using our formula that we have discussed several times, right? Our formula, minimum of max left and minimum of max left, max right minus our own height, right? So I copied it, our formula, right? Let me bring it. Uh, yeah, sorry. Let me copy it properly this time. And here you go. So this is our formula, minimum of max left, max right minus height. But there is a catch this time. Okay, so I want you to stay with me and see. So 4th index, its right is what? Its right max, its next greater right is 3 and its net greater left is 2. Perfect. And for 5th index, its next greater right is again, it's 1 this time for 5th, and next greater left is also 1, right? And for here, for 6th index, its next greater right is 3 and next greater left is 2. Okay, so here if we try to calculate the minimum, for example here the minimum is 2, so minus our own height. So here let's see, here 1 unit of water I can store, of course. Now let me show you here how much water I can store. Of course the minimum is 1 minus my height, that is 0, right? And now here how much water I can store, minimum that is 2, right, minus my height, so this much water. Now we never were able to trap water here, right? So count this water. That's gonna, we know that water is gonna trap here. But we never took care of it. So this time, what we are gonna do? Whenever we calculated, this time we are gonna calculate for the whole width. We are gonna calculate for the whole width. Okay, now let's see it clearly. Exactly what we are gonna do. Okay, I'm gonna break it into steps. First, first we know that we are gonna see how we are going to calculate next greater right. Then we are gonna extract our height, right? My, or you can say my value. Then next greater left. Okay, so I'm gonna build a stack this time and we are gonna understand it. So here is my stack. Let me erase it. Yeah, perfect. So first what I'm gonna do, first I see that here is 4, right? So I'm gonna push it index and value. Here I'm gonna write index and value. Right, now I've pushed 4. Now I see the next element is smaller. Right, next element is smaller. So what I'm gonna do, I'm simply gonna push it. My next element is smaller than the top element of my stack. So I push 2 and its index is 1. Now what is it? Let me write the indexes here. Okay, 0, 1, 2, 3, 4 and 5. Perfect. Now we see again our value is 0, which is smaller. So we are going to do nothing and push it in our stack. Now, now we are talking about our third index, that is 3 value. So we know that 3 is greater than the top element or top element of our stack, that is 0, right? So that means 3 is our what? 3 is our next greater right, or just right, just max right. Okay, and for which value? For 0th value. So I'm gonna pop, and here my value is going to be 0. And what is its next greater left? Whichever is the top element of my stack, that is 2 value, right? So by this, can I get to know how much water I can store? Of course I can know. So whichever is less minus my own height, right? The formula, minimum of NGR, next greater right, minus next greater left. Sorry, minimum of next greater right, comma, next greater left, whichever is minimum, minus my height. Okay, so that was our formula. So we calculated its height, how much water it will get trapped here. So here in this case, it is what? It is, for 0th value, it is 2 units, right? It is 2. So here I'm gonna trap 2 units of water, as you can see. Perfect. Now I'm gonna check if 3 is it greater than the top element of our stack. Yes, it is greater. So now again, this time 3 is again the next data right, for which value? For the top value of our stack, that is 2. We are gonna pop it, our value 2. Now what is the next data left? Again the top element of our stack, that is 4. So now we calculate that amount of water we can store. So for that, again, we are going to use our formula. So we can see 3 minus my own value, that is 2. That gives us 1. So here we can store 1 unit of water. Perfect. Right. 1 unit of water. Now what I want you to focus. I want you to focus on one thing. Right. So we realize that our next greater right here is 3, right? And next greater, sorry, 1 unit water is this. Perfect. Yeah. Okay, now I want you to analyze something. that is there any importance of width here? Is there any necessity of width here? I want you to think about it. Okay. And let's get moving. Okay. So now we check, is 3 is greater than our top element of stack? No, it is not. So this time I'm gonna push 3. So we push 3 with its index. Right. Now again we are gonna push 2 because it is less than the top element of our stack, that is 2, and its index 4. Right. Now you are gonna understand everything. Okay. So here our value is 5 and we see 5 is greater than the top element of our stack. Right. So for let me write it here. My next greater right is equal to 5. Right. Next greater left, I don't know, and my value is 2. My value is 2. I'm gonna pop this, and now the top element of my stack is my next greater left, that is 3. Right. And now I calculate the amount of water I can store here. So minimum of these minus my value, that is 3 minus 2 is equal to 1. So here that means I can store 1 unit of water. Perfect. Let's keep it doing, and I want you to see where we were unable to store water, right? What we did wrong. We did something wrong, right? We are gonna get it. We are gonna get it. Again, we want to check, is 5 is greater than the top element of our stack? Yes, it is. So for 3, uh let's write here. Okay, so this time our next greater right is again 5. Our value is 3. We are gonna pop 3. And the next greater left is how much? Next greater left is top element or stack, that is 4. So 4 minus 3 equal to 1. Right? So we are gonna store 1 here for 3. Let me use blue pen. Right. So what's the problem with our algorithm? That we never calculated this, right? This water trapped here as well as this water trapped here. So this time what we are going to do is to calculate it width, and we know how to calculate width, right? We are calculating the next data right and next data left through indexes. So we know the width, and what we are going to do are going to multiply it the total width. So here the total width between 4 and 5 is 4, right? So we are going to multiply 4 with our amount of water, and that is 1. So 4 into 4, right? So in our formula I got to add it however we are calculating minimum into width. Okay, so now let's try to code it. So we are given height, right? That is non-negative value. First, we are going to create our stack. We are required to calculate total amount of water trapped, right? So stack st equal to new stack. Now I'm gonna create a variable that water that's gonna store our water, right? So let's run a for loop int I equal to 0, right? We are gonna traverse all the height dot length I plus plus. Now first step, let's extract our height. So int value equal to height I. So that's our height. We extracted it. Now let's think about when we pop it, right? Whenever we are greater than the top element of our stack, right? So whenever we are greater than our top element or stack, so while first stack dot size is greater than 0, and if value is greater or equal to top element of our stack, so for that height and st dot peak. Okay, perfect. So whatever our I is, that is next greater right, my I. Okay, for what value? So for my value, that is the top element of my stack. So top element of my stack. So for that, I got a pop st.pop, so that I can also get my ngl, that is next greater left. So int next greater left is equal to whatever that is in the top of our stack, st.peak. Now that I have calculated next data right, next data left, now my task is to check now math dot minimum, right? Math dot minimum of what? Next greater right minus next greater left. Here water plus equal to, we have to calculate all the water, right? Math dot minimum next greater right, next greater left minus my height, that is value. Now we also discussed we have to multiply it with our width, that is, what is our width? We have not calculated our width yet. Let's do it. It's simple. So int width is equal to in next greater right minus next greater left minus 1. Also here, and we have to extract the value, right? So height ngr next greater right, to get the value height next greater left, right, minus my height into width and into width. Perfect. So this is our code. Now I want you to see one condition. So here, right, here what we are going to do, we have checked for everything, right? So now we are going to push 5, right? We are going to push 5 and its value is also 5. Now we are going to check. Now we are going to check if, yeah, so for 5 value, right? Sorry. So we got 5 value and we know that 5 is greater. So we know 5 is our next greater right. Again, 5 is our next greater right for which value? For 4 value. So I'm going to pop this. Pop my 4 value. Now, I know that here no next greater left exists, right? For 4 value, no next greater left exists. So what I'm going to do, if that's the case, then I'm going to simply break, because I know that my water can't get trapped if it got no next greater left, no building at the left that is greater. So here I got to write a condition. If stack dot size is equal to 0, then simply break the loop. Now let's try running our code and see if this works or not. Also I've not returned it, I think. So let's return it. Also if there's some error. Yeah. Return water. Right here. I have already used value variable here. Let it be current. Right. Also height st.pop, because it is going to store the height. You have to extract the value and minus current into width. Now let's try running it. Return water. Okay, small mistake. Wrong answer. Let's see why wrong answer. Okay, we have not pushed the element. Of course, we have to push the element. So here st.push I, and now run it. Wrong answer. A very small mistake here. We forgot to add brackets. Of course, we need to add brackets, and then after we get the solution, we have to multiply it with our width. Should work now. Let's try running it. Perfect. Finally accepted. I know there were a lot of mistakes, but some mistake happens. It's fine. Perfect. I hope you have understood the code. If you liked this video, thanks for watching.